Good morning, good afternoon, or good evening, depending on where you are, and welcome to another one of our JavaScript webinar sessions. In today's session, we're going to talk about the Universal Windows Platform apps and how you can build them with Node.js. So, just going over our agenda. So, first I'm going to give you a quick introduction of Universal Windows Platform apps. So, what are they? For those people not familiar with the Windows platform, just get a small introduction into that. And then we'll go to the meat of this presentation, which is the hosted web apps. So we will be building Universal Windows Platform apps using hosted web apps. And so we'll have quite an extensive introduction and lots of demos in how to use hosted web apps. And then finally, what we're going to do is we're going to look at how we can extend our default app experience with new features. And as mentioned here, there's going to be a lot of demos, technical sessions, so you want to see stuff working right. So as usual, if you have any questions, feel free to reach out to us on Twitter by using the hashtag AskMSDev, and we'll try to get your answers as quick as possible. Okay, so let's start. Universal Windows Platform. So what is the Universal Windows Platform, and then the apps that you can build on them? Now, if we look at Windows 10, which I guess most of you already know, you may have heard that Windows 10 is basically an operating system which can run on a multitude of device families, devices, as you can see here, ranging from so smartphones, phablets, tablets, over classic laptops, but just as well do we have Windows 10 running on, for example, the Xbox One or the HoloLens, and also added here right at the end, which may seem a bit strange, but also on IoT devices, such as, for example, the Raspberry Pi 2 or 3. So all of them are capable of running Windows 10. Now, as a consequence, by having this, is on top of this core Windows operating system, which runs on all of those devices, we have what is called the Universal Windows Platform. And what is this Universal Windows Platform? Is basically, as mentioned here, it's a single API service. So it's a set of libraries and APIs that you have available to you as a developer for you to build applications on Windows 10. So basically you will be building applications that you can then deploy into the Windows Store, which can then be made available across all of these devices. And the nice thing is of this API service, this Universal Windows Platform set of APIs, is that they are guaranteed across all of those devices. So you have the same APIs available regardless whether you're building an app that is running on the desktop, on the phone, on Xbox, on HoloLens, or on IoT device. Of course, there are some things that you may need to tweak in terms of user experience. So for example, if you have an application that is running on a smartphone but also runs on Xbox, so on your TV screen, you'll have to do some responsiveness, of course, that your application really scales to this big screen. And also, if you run it on an IoT device which does not have a display, there's some things that you need to take into account, of course, when building for a specific device. But underlying message, the APIs are all the same. Now, building a Windows app on top of that then gives you, of course, if you build your application once using this UWP APIs, you basically run that same application on all of these devices without having to basically change a single line of code if you don't want to. And so you can kind of just take your app code and just deploy it to any other device you want to. And as mentioned, of course, sometimes you have some capabilities that are existing on a given device, or which don't exist on a given device. So, for example, a smartphone allows you to make phone calls, which you don't necessarily have on your desktop, or which you may not have on an IoT device. And so you may want to have some testing of capabilities and adjusting your user experience. Now, what are kind of your options for building universal Windows platform applications? So there's really a lot of options for you. And the first one of which is of course you can build a native application. So you are using either C# or VB together with XAML for your presentation logic, and then build that universal Windows platform application. So you're calling into those unified APIs. Other option for building native applications is to use C++ and DirectX. And even, and this is something I'm going to touch upon in next week's webinar, is you can actually use web technology as well. So you could use JavaScript and HTML for building a native universal Windows platform app, which is kind of cool. So it's not just running in a browser, it's really generating native. It's a native application, and a lot of the built-in applications that are running on Windows 10 that come out of the box have been built using JavaScript and HTML. So they're actually web technology that you can use. And then of course there's other options for native applications such as Xamarin, or using game middleware such as Unity or any of the other game engines. Unreal Engine is not marked here, but you could do it just as well. So this is kind of the native application story. Then next to that, other option to kind of build this universal Windows platform app is to build what is called a hybrid or a packaged application. This is using Cordova or PhoneGap as it used to be. So you're basically using web technology, and you're packaging that web technology, those HTML, JavaScript, those CSS files inside of your application. So you're packaging all of that up into your application, and you can call into the Universal Windows Platform APIs. So this is the typical Cordova PhoneGap type of application. So you're basically interpreting. It's like running a mini browser inside of your application. And then finally, and this is going to be the main topic of this session, which is what we call hosted web apps. And there's again different ways to create those hosted web apps. We'll look at Visual Studio way and also the Manifold.js way to build a hosted web app. But what is a hosted web app? It's actually pretty simple. It's kind of surprising as well. But let me just to make the difference. So I talked about the hybrid applications or packaged applications, where basically you are putting all of your web code inside of the application. So you deploy your application into an application store, and basically all of the codes, all of the things that you want to present in the application are included in that package. So it's inside of the application, which kind of course gives you the advantage that you have a great offline experience, because all of the code, all of the presentation logic is sitting inside of the application. Now, on the contrary, if you look at hosted applications, basically what is happening is your application code, or the presentation, all of the application logic is not sitting inside of the application. It's basically sitting on your server. This may sound a bit surprising, but basically this is how we're going to do it. We're going to build a Node.js application, and we're going to wrap that inside of a hosted web application. But the code for the application is sitting on the server side. And this kind of has the advantage of the application always being up to date. You don't have to push an update to the App Store to get new logic inside of your application. As you modify code on the server, automatically it shows up in the application. This as opposed to the packaged applications, where you need to publish new application content through the App Store to make it available to your users. So your turnaround time for pushing updates is a lot shorter with hosted web apps. Of course, there's but we'll discuss that in more detail. There's the question: can we work also in offline mode, like we have in a packaged application? And we'll look at that. And then a third option, which I didn't really mention in here, is which basically you can create pretty much a native application, and you're hosting basically a browser control inside of your application. So you can combine packaged content as well as hosted content. So you have your some files could be packaged inside of the application, and then for the things that you want a quick turnaround time, where you want to have content hosted on a server, you can get access to them through a browser control. Of course, this comes with some kind of how do you sync whatever is running in the browser control and what is in the local application itself. So there are some things you need to look into to make that work efficiently. Okay, so packaged, as I said, Apache Cordova. But let's now dive into hosted web apps. So hosted web apps, basically it looks like from the outside, from a user perspective, it looks like a native application. It doesn't look different than any other native application. That is, of course, if your web applications, web code, of course, is responsive and deals with touch, of course. So have your device, you have the application sitting on it, and basically the actual application is just a container. And we'll look at that in more detail. There's basically a default hosted web app just contains a single file, which is an application manifest, which points to the location where your hosted website is located. So we have like an empty container, which is a hosted web app, and then basically on your website you have your web application. Could be developed in Node.js, could be PHP, could be Ruby, could be basically any web technology that you want to use on the server side. It's really agnostic in terms of the hosted web apps. Because all of the code is sitting on your website, creating this hosted web app is just a matter of minutes. It doesn't even take minutes for it to create it. So it's really, really easy and really fast to create that hosted web app. Okay, so why do you want to do it? It's basically, well, it gives you quick turnaround time for making your existing website available through an app. So you're leveraging your existing knowledge, your existing investments that you've already done in website development, so you don't have to learn a completely new paradigm for development for creating this mobile front end for your website. And the final point here, and we'll look at that in more detail towards the second part of this presentation, is that you can actually extend your website with native logic, with access to features that you have on the Windows platform. So this is going to be something really nice to see. Now, enough talk. Let's switch to a demo. So the first demo, we're going to look at how can we create this hosted web app. Talked about minutes, so let's demonstrate that we can do this in minutes. So what you see here is basically the code for my Node.js web backend, just to show you what it does. So I have here, it's basically a chat server application. If I run my application here, so F5ing this one, so it's starting up, and just open up my browser and just go to localhost port 3000. So it's a local Node.js application. So it's basically allows you to give chat messages. Say Robert is here, something like this. And if we have another browser window, we can connect to it. Here we're connected as Clark Gable. Robert Young is also connected, and Robert Young said is here something like this, like here. And if we switch back to our other window, we can see the message. So it's a very simple chat application. And what we're going to do is we're going to wrap this chat application inside of a mobile application. So how do we do this? So I'm switching to Visual Studio. So you can get Visual Studio, just go to visualstudio.com, and we have a free community edition that you can download and use for free. So what we're going to do, we're going to create a new project. So in Visual Studio you have a whole range of project types that you can create. For this specific case, to create this hosted web app, what we need to do is we need to create a universal Windows application, but we need to create one which is based on JavaScript code. So we go to JavaScript Windows Universal, and we're going to start off with a blank template, blank app template. Just give it a name, and let's call it my chat app. There we go. So it's now creating the project. So what we'll see is by default this contains a default HTML page, which is kind of the landing page for launching the application, which is sitting locally. But that's not what we're going to use here. So looking here at the Solution Explorer, so we have our Universal Windows Platform application. There's some CSS in here, there's some JavaScript, there's some index. Because we're going to use a hosted web app, we can delete all of the local stuff here. So all of this we're going to delete because we don't need it. The images we're going to keep because these are basically the images that we're going to use for a splash screen for publishing to the store, so application logos and so on, so we can keep those. So the important file here that is going to make our hosted web app possible is our application manifest. So if you just click on this one, so this is an XML file, but in Visual Studio we can represent it through kind of a more visual experience. But you could look at the XML version as well, which is by clicking here, right-clicking and say View Code. It will show you the XML that's behind it. The first thing we need to change for our hosted web application is, well, we need to tell our Universal Windows Platform app what the starting page is. So in here it pointed to our local index.html file, which we don't have anymore. So we're going to switch it to our chat server. So let's change it to localhost 3000. Note that in here I'm using just localhost, but it could be running anywhere. It could be running in your data center, could be running in some cloud platforms such as Azure or AWS. It could be running anywhere. So we mark our start page, and next thing that we need to do is you see here content URIs. Basically we need to tell our Universal Platform application what are kind of the URLs that we want to have accessed through our Universal Windows Platform app. Any URL that you have on your web backend which is not marked in here will be opened in the browser. So if you have an existing web application that you wrap inside of a hosted web app, and there's a link in there which points to an external site, for example, well, if you click on that in the app itself, it will open up the browser. So unless you add it here, it will open up inside of the application. Okay, inline inside of your mobile app. And this is what we want. So just saving this file. And that's basically all we need to do to create a hosted web app. So we modified our manifest to point to the right starting page, and then we mentioned what is kind of the web pages that we want to have included inside of our mobile app. And then if we can start the application, just go to run it on the local machine here. As I have a Windows 10 machine, it's going to compile, deploy it locally, and there we go, our application launches with the default splash screen. And here we can see our chat app is running inside of a Universal Windows Platform application. Okay, sorry about that. So you can see that we have our two users which are in the browser. So I can start, I can say King here. If we switch to our browser, we can now see it's in here. So we have a browser and we have our mobile backend for our chat application. So nothing really extraordinarily difficult to get it to work. Okay. Now you may wonder, what if I don't have Visual Studio? What if I'm running on a Mac or on Linux? Can I also create these Universal Windows Platform applications? Okay. So for that, I'm just going to close this one here. There is a solution, a community project. It's open source, which we are basically contributing to. A number of our engineers are working on this project. It's called Manifold.js. It's basically a way to create hosted web applications cross-platform and cross-device. So you can create those universal Windows platform apps, but just as well you can generate iOS or Android apps using just the Manifold.js tooling, just command line tooling for you to use to generate these hosted web apps. So you have support for a number of platforms here. So you could do so again, similar to what we've done in Visual Studio. We point to a URL and we generate an app. We'll be doing the same thing with Manifold.js. So a quick demo here. So for this I'm going to switch to my command prompt. So just to show here, I have just an empty folder. And to get all of the Manifold.js tooling, what you need to do is do an npm install of Manifold.js, which I've already done. But this is how you get it, and you may want to install it globally by give it a -G. So once you have done that, you can just launch Manifold.js. And what we need to provide is the starting page for a hosted web application. So for this, in our specific case, we're going to give it localhost 3000 again, and we're going to specify for which platform we want to generate our application. So in this specific case, I want to have a Windows 10 Universal Windows Platform application. We just give it the platform Windows 10. If you don't specify the platform, it's going to generate hosted web apps for every single platform that it supports. So here you get a number of warnings saying that there's that you will be needing some logos, and it's generating some default logos for you. Okay. So if you just look at the directory, what you can see here, we have a directory localhost. If you go to localhost, which corresponds to our application, our URL. So in here we have a folder for our Windows 10 project. Okay. Now, what is all in there? I can open it up in code to show you the files. There we go, our code editor. And looking here, what we'll see is our Windows 10 folder. There's a manifest that was created. So this is kind of the XML version of the manifest. So you can see here we have our application, we have our content URI rules. So we're including, this is kind of the pages that we want to have included. And we have our start page, which is sitting here, our localhost 3000. Okay. And so alongside that we have a JavaScript project which you can then import again in Visual Studio if you would want to. Now, how can we run this application? So we've generated our project using Manifold. The only thing we can do what we can do for running it is just Manifold.js run and then Windows 10. We want to run the Windows 10 version. So it's launching the app now. This is going to run through some PowerShell just to register the app on my local machine. So this just takes a few seconds. There you can see now it's deploying the application. After it has been deployed, it will run the application, and it should look exactly the same as the app that we generated using Visual Studio. Because basically the app itself is pretty much empty. It has just a pointer going to our server-based application. Okay, so here you can see again we have our users. There's only 3 now because the other one was disconnected. So again, you could use Manifold.js if you want to create those Windows 10, those universal Windows platform apps from your Mac or from your Linux machine, or if you don't even have Visual Studio, you could use Manifold.js. But basically the exact same logic applies here. And you just create this container, which is pretty much empty, which points to the server-side code. So this is the first basic kind of workflow that you have with creating hosted web applications. Now, as I mentioned, everything is basically sitting on the server. Now, what happens if there's no connectivity? By default, if you don't have any network connectivity, your application is going to blank out because there's no content to reach on the server side, and this is not the experience that you want to have. So one way to deal with this is you can use, of course, the standard web technologies such as IndexedDB or app cache to provide some offline experience for your application. So you just cache some data, some pages inside of your application. It works exactly the same as it would work when building a normal web application. So you can use the standard web technologies, but what we have built in is, as you can see here, we can provide a basic offline page just by putting a msapp_error.html page inside of our hosted web app. So we have a packaged HTML page. This one will be hit every time there is a connectivity issue. Once you would, if you would have an HTTP 404, it will redirect to this offline page is sitting inside of your package. Of course, you can make this as simple or as rich as you want. So this offline page can be just saying that we have a network issue. Just wait or retry in X number of time, or you can completely customize it. You can make that a full-fledged application experience where you allow the user to do local logic, just continue to work locally, and then once your connectivity comes back, you can continue in a connected mode. And the thing you can do is you can actually switch between local and remote pages as well. So you can have from your web server, you can point to local web pages. So for example, if you have in your server-side code a link which has this msappx web syntax, this will basically point to a page that is located inside of your application. On the other hand, from this local page, you can point to, of course, resources that are sitting on the internet, that are sitting on your application backend. So you can have communication or a combination of local and remote pages inside of your hosted web application. So it does not necessarily have to be sitting entirely on the server. You can combine and have some logic sitting inside of your application as well. So let's show you how this works. So in this specific case, I'm going to continue with the Visual Studio version here. So what we're going to do is we're going to add an HTML page, which corresponds to our standard offline error page. So we just add a new HTML file. So this one needs to be called msapp.error.html. There we go. And the mere fact of having this file inside of your package will automatically, so once there is an HTTP 404, will redirect to this specific page. So then we could say here, connectivity dropped. Please try again later. And we could add also here, for example, an href to our localhost 3000 and say reload the app, something like this. Okay. Just for demonstrating how this works, well, I can't disconnect my my network here, otherwise we would drop the stream. So for this, what I'm going to do is I'm going to deploy inside of an emulator. I'm going to use the Windows Phone emulator for running our hosted web application. So this is what I'm doing here. I'm choosing the mobile emulator. So this is going to start just the Windows Phone emulator. It's going to start up the application. So this already shows kind of the advantages of Universal Windows Platform. I'm not changing any code here. It just deploy it to a mobile emulator as opposed to just my desktop. So there we go, the application starts, and here we have our application running as we expected. Okay. Now, one of the things we could do in the emulator is we can just go to network, and we have network simulation. We could say network speed is we're going to disable the network connectivity. Okay, so if we just here close the application and we go to our chat app, of course it's still running, so it has cached the application. Let's close it entirely, launch the chat app, so it's starting it up. We should hit the network connectivity issue. So as it starts, this is taking some time. Let me just launch it through Visual Studio again. Seems to be an issue in starting the application. There we go. So here we can see that we are arriving on our default error page. So we don't have any connectivity. So this here is now pretty simple. You can make it, as I said, as complex as possible, as you want. So we can try to reload. This is not going to result in any results because it still has no connectivity. If we, on the other hand, switch back to, for example, 4G, so we have connectivity again. If we reload the app, there we go. So we are back in our application with connectivity. Okay. So that's basically how you provide this offline experience, or a very basic offline experience here. But as I said, you could just as well add or include any pages here locally. So if we have, for example, here we add a local page. So I'm going to add a new HTML page, and let's call it local page.html. And note that you can have HTML and JavaScript and CSS also included in here. It does not necessarily have to be just pure HTML. You have the full web stack available to you. So this is a local page. Now what we're going to do is we're going to invoke this from the server side, because we want to have a link in our application to call into local application logic. And then we're going to add here, let me just copy this one here. We're going to call back from our local page to our app again. So what we need to do here, our application is kind of finished. We have a local page, and we want to invoke this from our web server code. So for this I need to switch to my application. I'm going to stop it here for a second. So here you have, it's using Express JS. So what we're going to do is just going to add a simple link here. So href, go to local page. There we go. And our href is going to use, as I mentioned here, something like this. And this should then be local page.html. Let's see if that works. So we fire up our application here, our server side. So of course, if you run this on just in the browser, this is not going to work, of course, this link. So we have our application up and running. If I now switch back to our mobile application, I'm starting the application again. So the application starts. So you should see here our link. So what I've done, just to kind of point out again, is we're changing code on the server, and this appears in our web application. So if I click on this go to local page, we navigate to our local page, which is sitting inside of the, which is packaged inside of the app. If we go back, we're switching back. So this is how you can add both packaged content as well as hosted content on the server inside of your Universal Windows Platform app. So just using this kind of special syntax of URLs, of navigating to pages, you can actually navigate to local pages inside of your application. And basically the hosted web app infrastructure here will detect that you're pointing to a local page. Okay. So let's stop this once more. Switching back to some slides. So offline experience, so the default experience, we can add some packaged pages to provide a more rich offline experience, or have a combination of packaged and hosted content. Now, this is all nice, but of course, if you build a mobile application, you want it to be more rich, of course. You want it to use the capabilities of the device and the capabilities of the platform it's running on. So in this specific case, with the Universal Windows Platform, it has a whole range of, it has hundreds of APIs available to you, and that allow you to kind of customize the experience of the mobile app on your device. So first one of which is live tiles. So if you look at Windows 10, as you can see here, you basically have what we call these tiles, which give you kind of information, and that's why we call them live tiles. So they kind of provide you information about emails that has come in. So you have badge information, you have some preview message, maybe you have some visuals for a weather app, some recent apps that were added to the App Store, and so on and so on. So these rich experience, these launchers, will give you this extended experience on Windows 10. So it would be nice, of course, if we could add this to our application, of course. Yeah. But also, there's things like toast notifications. If something important happens in the application, we want to receive a toast notification. A notification message on our device, or we can go even further. One of the features that you have in Windows 10 is Cortana, so a personal digital assistant, so similar to what you have, for example, with Siri or Google Now. You can use voice to direct, to command your system, your device to do something. Well, you can integrate Cortana and speech recognition with your hosted web application. So you could start your hosted web app using speech. You can direct and navigate to specific pages inside of your application using speech, all inside of a hosted web application. And note, all of these things we will be doing by modifying server-side code. We won't be changing anything inside of our locally deployed application. So this is really important. All of the application logic will be sitting on the server. And some other examples that you could see here, well, we can get access to a calendar, so we can create a calendar or a meeting request on your local agenda. You could choose contact information, so if you have your, so in Windows 10 we have a people app where you have all of your contacts. Well, you can, inside of your web app, a hosted web app, you can get access to those contacts if you'd want to. This, of course, next to getting access to hardware, of course. Very often mobile applications get access to whether it's geolocation or the camera, but just as well we can get access to, for example, NFC sensors or Bluetooth sensors. So your mobile application, your hosted web app, could even be activated through hardware, for example through NFC. As soon as somebody approaches and taps their device on some NFC tag, that could launch up your hosted web application and basically launch your server side, the code that is sitting on your web server. It's again quite impressive to see how that works. So let's demonstrate how this works, what you need to do for this. So I'm going to switch again here, and let's switch again to the local machine so I can demonstrate. One of the things we will be doing is, so we have our hosted web application which uses our chat server. So this one I'm going to close off just to get it out of the way. So our web server here, it's up and running. As you can see here, our Node server is up and running. So one of the things we're going to do first is we're going to add a live tile. So as soon as we receive a chat message, we're going to modify the live tile for our hosted web application. Yeah. To see that work, what we're going to do is we have our I should have my chat app. I'm going to pin it to my start screen so we can see it appear. So in right here, I'm just going to put it all the way here at the top so we can really see it. So this is our live tile for our application. It's the default one. It's fairly static. There's nothing live about it. It's just a shortcut to launch the application. So how can we add a live tile? How can we get access to these Windows API, Windows Universal APIs from our server-side code? I'm just going to stop our application here. And one of the things we're going to do is, here you can see a number of functions. So we are using WebSockets to connect to our server side to display logic inside of the application. And what happens is, as soon as we get a server message, so let's say here, so let's this should be update live tile. And so we're going to say update. Do I have any? I already prepared an empty method here, update tile, which I'm going to invoke. So it's currently empty. So as soon as we have an update chat, so somebody is sending a chat message, we're going to specify here our username and our data. And I think that should be it in terms of, we can leave the other ones just null. So how do we get this tile information? How do we get access to our Universal Windows Platform APIs? So first thing, of course, we need to kind of differentiate, are we running on the web server, on a website in the browser? Because our web application could be running in the browser. As you can see here, it could be running here, but in the browser we don't have access to those Windows APIs because we're not in a mobile application. So we need to check, are we really running inside of the context of a hosted web application? I'm going to grab here a snippet, and let's just grab here our update tile, and I'll explain in just a minute what all this code does. So let's just replace this. So the first thing we're doing is we're going to check, do we have the Windows object? Yeah. So this is kind of the namespace that we're going to use here for tile notifications. We need to windows.ui.notifications namespace to be available to us inside of the context of our web application. Yeah. So if we don't have the Windows object, we don't have Windows UI, Windows notifications, we actually do feature checking here. Are we capable of sending basically tile notifications here? This will, once we're running in the browser, this Windows object will be undefined, so we won't be doing all of this logic here inside of the browser. We're just going to alternate behavior, which could be just an alert window that we're popping up or something else. But if these objects are available, which will be the case when running inside of our Universal Windows Platform app, what we can do is we can create a notifications object. Basically, setting a live tile is just a matter of creating an XML structure. So here we create a tile template, which is just an image and some text. We're going to get some random image in there, and we're going to put the username, which we get from here. The message that we get, we'll put there as well. And then we're actually going to use notification.tile update manager to create basically our live tile for us. Yeah. All of this is code that is belonging to the Universal Windows Platform APIs. And note, as said before, all of this is code that is running on our server. So you're updating your web server. We haven't changed anything here in Visual Studio. In here, we didn't change anything to create a live tile. Yeah. So just with this, I'm going to start our Node server. I'm just pressing F5 here, so I can start up my Node server once it's there. Okay. So one of the things when we run our application now locally, what we should see is that the application invokes, it gets some chat messages that were already sent into the stream here. So Robert, Clark, King, and there's plenty of people there. Just a history. If we now go to our start page, let's hope we can see our live tile being updated, and this might take a few seconds for it to update. Seems to be taking longer. Let's say seems to be some connectivity issue. Okay, we've got this one. Do we get our... Let me just add it. There seems to be something wrong here. Let's unpin it and try to pin it again. No, something seems to be not running well here. So update my tile. Well, it does not seem to want to update our tile message. Let's see if I can quickly see what's going wrong here. Update tile. We should not have an URL. So we have our update chat. We have this one here. And quickly looking why this does not work. Let's say this is just do this because I've seen it before that sometimes the username, or let's just escape our data. Maybe there's some fishy characters in here. Run it again. So I'm updating my server, hopefully to make my client-side code run again. Quickly going to start again. Oh, I know what's going wrong. So one of the things that we have here, which I didn't mention, is in our manifest. In our content URIs, there's one specific setting that you need to be aware of, is the WinRT access. So by default, your web pages don't have access to your Windows platform APIs, just for security reasons. So by default, you can't just invoke them, unless, of course, you explicitly mention that pages coming from this URL, they have full access to the Windows runtime APIs, so the Windows platform, Universal Windows Platform APIs. So just by updating this, we should now be able to, and let's just remove this again. and put it back, just restarting this one. So restarting our server. Of course, we need to give access to our APIs. So once we've done it, we can kind of get access to all of the APIs that exist. So our backend is running, our client application is now deployed. And let's see, so we get some messages coming in. Adding our chat app again. Oh, sorry, there we go. Pin to start. Let's see if we can. We're back. And let's hope we can get a tile update now. It's again taking a couple of seconds. Well, let's move on to the next one. Well, maybe they'll come true. So let's just stop this one here. And what we're going to do now is in a second step, we're going to, as soon as somebody connects to the chat window, we want to receive a toast notification. And this is what we're going to do here. So as soon as somebody is connected, this is in the server notification, we get a connected message or a disconnected message. We want to basically here send a toast. So in here, if somebody connects, send toast, we're going to say here data dot username plus something connected to chat. Something like this. Okay. Let's just let's just take the code for, and again it's fairly similar. So I'm going to go over it just a second. I'm just copying it here, switching back to our update tile. What I've done here is I've pasted here the send toast method in here. So the first step again that you're seeing is we're checking, are we running inside of a universal Windows platform app? So is the Windows object defined? If yes, again, our toast message is a matter of filling in some XML structure and then creating a toast notification, just showing that toast message. Okay, so I'm just going to start my server, which is happening here. So I'm starting my server, and then as we start our chat universal platform app, we can see a toast message appear because I have connected. Let's connect somebody else. Let's just do a localhost 3000. So George Arliss connected to the chat, which you can see here. If I dismiss this one, if I just refresh the page, we can see that we have Edmund Gwen has now connected to the chat. So on my server side, creating some massive toast notifications, so all code setting on the server, which will impact my experience on my local device here. Yeah, so I didn't change anything inside of the app itself. It's just server-side code. And as you can see here, finally our live tile has updated. So it's showing some random image, and it should kind of flip over and show you Lana Turner, we're back, which was our last message that we got here. And we could say admin, I'm leaving soon. As this message is sent, we should have a tile update, and so if this one saying here, Edmund Gwen said, I'm leaving soon. So our live tile is now working. There must have been some network issue. Okay, so this is live tiles toast notifications. One final thing I want to show you here is how can we get access to, for example, NFC devices. Yeah. And for this, what we're going to do is I'm just going to close this one off. We still have one that has been connected. So one of the things we're going to do is just here I have a register for NFC connections. I just need to call into this. So I'm just going to call this register NFC connections. There we go. I think that should be it. Just this method, which we're going to fill in here. Just copying it just to be sure. Going to my snippets here. So one method I have here is for registering our application with NFC devices. So again, in our server-side code, I'm just going to replace this one here. So one thing you may notice is, and this is kind of a glimpse that I have here, if this one is not defined, which I need to add, because here I'm not doing feature checking in the browser, this would fail. So let's do this. Just add here another parentheses. So we're registering NFC connections. We're just invoking this. What are we doing here? Basically, we are getting the default NFC device, so proximity device. If we have one, we're going to add a listener. A listener if a device comes near, so if there's a device that actually arrives and taps our device, we're going to change the background color of our application to green. If the NFC tag is then removed from the device, we're going to change the background color to red. We're just setting the color just to demonstrate. Now again, I'm going to run, so this is all we need to do. Just starting this one. And for demonstrating this, I'm going to again launch the mobile emulator, because I have NFC emulation there, or simulation. So we're starting the application. You'll see the same toast messages appear here, but then using kind of the Windows Phone paradigm. So you connect it to the chat. So we have our message appear here. And then in NFC, what we can do is we can now simulate a NFC tab. Let's see if it's happy to... it doesn't seem to be happy. And once again, this is something that I need to modify here, is next to our URLs, of course, if you want to use capabilities such as camera or NFC devices or proximity, we need to specify the capabilities, and that you can actually, the user needs to give them their consent that you want to have, that they want to expose their proximity. So we enable the capabilities here. So you have camera in there, you have the contacts information as well. So just save this, run the application again, and now we should be able to get proximity information, so the NFC capability. So our application starts. We'll probably see another notification. Yes, we can dismiss this one. Now if we let's tab. Sorry about that. There seems to be another glitch happening here. Let's see if we have used the proper function name here. So we're registering our NFC connections. Let's just start it again. I was hoping to show you this one. There we go. Our server runs. Let's just quickly restart the app on the device. There we go. We are running. The application is up and active. And if we now tab, well, something seems to be going wrong here. We have the proximity capability enabled, and tapping, untapping should work. I'll share the code if and check what's going wrong. But basically, you should be able to kind of get NFC detection, so get hardware access straight from your server-side code, so straight from inside of your web application. We should be able to register in this specific case for NFC, but just as well, and let me just quickly, while we're going towards the end of this this live stream, you should be able to get also access to the camera, for example. So you could go to Windows Media Capture Camera Capture UI. It will open up a UI for the user to take a picture with the webcam on the device. And just as well, we can get access to contacts, the address book sitting on the local device, and select here, for example, the contact display name. So the user can select inside of the People app what is the contact person, and you can get that information straight inside of your web application. Okay. So sorry for the glitches that we had in the demos. So I hope with this you got kind of an introduction to what hosted web apps can bring you. So you can just leverage your existing server-side code. So in this specific case, your Node.js code. Expose it as a mobile app. We've looked at how to provide kind of an offline or a hybrid experience where you have both hosted and packaged content. And then secondly, we looked at how you can call into these universal Windows Platform APIs, adding live tiles, those messages, getting address book information, connecting to NFC devices or cameras, so get hardware access for your application. So all of this using code that is sitting on the server, so quicker turnaround times as opposed to having to republish a new version of the app inside of the store. So here are a number of links, so we'll be sharing the deck as well as the recording on channel 9. If you have any more questions, just reach out to us on Twitter using #AskMSDev hashtag. And with that, I want to thank you for joining us in another one of our JavaScript webinars. I hope to see you soon. Bye. Good morning, good afternoon, or good evening, depending on where you are, and welcome to another one of our JavaScript webinar sessions. In today's session, we're going to talk about the Universal Windows Platform apps and how you can build them with Node.js. So just going over our agenda. So first I'm going to give you a quick introduction of Universal Windows Platform apps. So what are they? For those people not familiar with the Windows platform, just get a small introduction into that. And then we'll go to the meat of this presentation, which is the hosted web apps. So we will be building Universal Windows Platform apps using hosted web apps. And so we'll have quite an extensive introduction and lots of demos in how to use hosted web apps. And then finally what we're going to do is we're going to look at how we can extend our default app experience with new features. And as mentioned here, there's going to be a lot of demos, technical sessions, so you want to see stuff working right. So as usual, if you have any questions, feel free to reach out to us on Twitter by using the hashtag AskMSDev, and we'll try to get your answers as using this UWP APIs. You basically run that same application on all of these devices without having to basically change a single line of code if you don't want to. And so you can kind of just take your app code and just deploy it to any other device you want to. And as mentioned, of course, you sometimes you have some capabilities that are existing on a given device, or which don't exist on a given device. So, for example, a smartphone allows you to make phone calls, which you don't necessarily have on your desktop, or which you may not have on an IoT device. And so you may want to have some testing of capabilities and adjusting your user experience. Now, what are kind of your options for building universal Windows platform applications? So there's really a lot of options for you. And the first one of which is of course you can build a native application. So you are using either C# or VB together with XAML for your presentation logic, and then build that universal Windows platform application. So you're calling into those unified APIs. Other option for building native applications is to use C++ and DirectX. And even, and this is something I'm going to touch upon in next week's webinar, is you can actually use web technology as well. So you could use JavaScript and HTML for building a native universal Windows platform app, which is kind of cool. So it's not just running in a browser, it's really generating native. It's a native application, and a lot of the built-in applications that are running on Windows 10 that come out of the box have been built using JavaScript and HTML. So they're actually web technology that you can use. And then of course there's other options for native applications such as Xamarin, or using game middleware such as Unity or any of the other game engines. Unreal Engine's not marked here, but you could do it just as well. So this is kind of the native application story. Then next to that, other option to kind of build this universal Windows platform app is to build what is called a hybrid or a packaged application. This is using Cordova or PhoneGap as it used to be. So you're basically using web technology, and you're packaging that web technology, those HTML just as quick as possible. Okay, so let's start. Universal Windows Platform. So what is the Universal Windows Platform, and then the apps that you can build on them? Now, if we look at Windows 10, which I guess most of you already know, you may have heard that Windows 10 is basically an operating system which can run on a multitude of device families, devices, as you can see here, ranging from so smartphones, phablets, tablets, over classic laptops, but just as well do we have Windows 10 running on, for example, the Xbox One or the HoloLens, and also added here right at the end, which may seem a bit strange, but also on IoT devices such as, for example, the Raspberry Pi 2 or 3. So all of them are capable of running Windows 10. Now, as a consequence, by having this, is on top of this core Windows operating system, which runs on all of those devices, we have what is called the Universal Windows Platform. And what is this Universal Windows Platform? Is basically, as mentioned here, it's a single API service. So it's a set of libraries and APIs that you have available to you as a developer for you to build applications on Windows 10. So basically you will be building applications that you can then deploy into the Windows Store, which can then be made available across all of these devices. And the nice thing is of this API service, this Universal Windows Platform set of APIs, is that they are guaranteed across all of those devices. So you have the same APIs available regardless whether you're building an app that is running on the desktop, on the phone, or an Xbox, on HoloLens, or on an IoT device. Of course, there are some things that you may need to tweak in terms of user experience. So for example, if you have an application that is running on a smartphone but also runs on Xbox, so on your TV screen, you'll have to do some responsiveness, of course, that your application really scales to this big screen. And also, if you run it on an IoT device which does not have a display, there's some things that you need to take into account, of course, when building for a specific device. But underlying message, the APIs are all the same. Now, building a Windows app on top of that then gives you, of course, if you build your application once,